Hey everybody, this is Waehner from Confluent. Today I want to talk about streaming machine learning with Apache Kafka and its ecosystem. This way you can deploy machine learning in the real world without using another data lake. So let's get started with the session. So today in this short session, I will talk about an example with connected cars. This is perfect for streaming a lot of huge volumes of data and process it. For example, for doing predictive maintenance or after sales in this business case. In this example here, we don't have machine learning in here. So this is just a streaming pipeline, like how many people start to build that. You collect a lot of data from many different interfaces, then you process it and ingest it into other systems. These other systems can also be built with the streaming platform, like a real-time monitoring system, or they can be batch analytics platforms, like a data lake, like Spark or something like that. So that's totally up to you and very flexible. But this is how you often build your pipeline from the beginning. And then the good news is to add machine learning to that. It's really not that complex. You just add a few other consumers which use the data. Like in this example now, we have added machine learning here in green. And machine learning, as you probably know, is always two steps. It's the model training part, which we do here in the middle. So here we consume a lot of data from the streaming platform. In this case, it's the historical data from a lot of cars. And then we use that to train an analytic model with any favorite technology like TensorFlow or H2O or a cloud service. And then separated from that, we need to deploy the model somewhere. In this example on the right side, we just enhance an already existing application and use the analytic model to do inference here. So in this case, the business logic is improved. And that's what I see in the real world a lot. It's not just about building completely new use cases like a chatbot with deep learning, but it's also about improving existing applications which use other business logic before machine learning. So in this architecture, you see how easy it is to complement a streaming platform with machine learning technologies. So let's now go a little bit deeper into that. When we talk about a streaming platform, actually, in most cases, we talk about Apache Kafka, which is the de facto standard around the world in the end. And what's important, even if you know Kafka for ingestion layer into a data lake for machine learning, Kafka is much more than that. The heart of it is a combination of messaging and storage for huge volumes of data, but still providing a reliable fault-tolerant system at scale. And with that in mind, you can build mission-critical workloads. So the ingestion into a data lake is just a fraction of use cases. We see really customers deploying machine learning, but also many other mission-critical workloads with Kafka. And also it provides connectivity with Kafka Connect. So you can integrate to all these different sources and things. And last but not least, you can also process the data continuously with Kafka streams. That's all part of Apache Kafka. And that's what many people don't know from the beginning. They only use Kafka as ingestion layer and don't use all these other benefits. But that's what we will do here today. So if you take a look at Kafka from the machine learning perspective, it's very complementary, as you can see here. I mean, machine learning is always starting with model training. So you collect data, you transform it, and then you have a batch process for doing model training. So here, Kafka is a perfect solution for doing the integration to that before you train the model with your Python code or Jupyter Notebook or something like that. But in addition to that, you also need to deploy the model to production. And this is also very often done with Kafka because here it makes so much sense to have low latency, high reliability, and all of that around Apache Kafka. So in addition to the messaging platform in the middle, in most machine learning projects I've seen around Kafka, also other components are used. For example, the connectors to connect to the streaming data from the IoT systems, or to ingest the data into another data lake or database. So that's totally up to you how you architect it. But with machine learning, you can help the integration layer for model training, but also the model inference layer. And in addition to these two important layers, also about the monitoring and observability of your training and of your scoring pipeline. So this is why we see so much Kafka in machine learning projects these days. Well, and in the model training part, we also see that many people don't use a data lake anymore. You don't need something like HDFS or S3 in addition to Kafka. You can do that, of course, like training a model with Spark then. But also what's possible today that you connect directly from your machine learning framework to the Kafka stream of data. Like in this example where we use TensorFlow IO to directly put the TensorFlow engine and connect it to Kafka without another data lake in the middle. This totally simplifies your architecture and makes it less costly. So for many use cases, you don't need another data lake just for machine learning. And the other important part where we see this more and more is that now you can also use tiered storage for the Kafka. With that, you can store data forever in Kafka, like in your favorite data lake like Hadoop. Because it's also an object store under the hood in the same way. So you have low cost, but still can store all the data and scale this. And with this in mind, you can use Kafka not just for real-time data, but also for the decoupling and for processing historical data, like for model training. So this is why tiered storage is such a great game changer for Kafka. This example here is from Confluent, which we use in production in our cloud service and provided for our customers using our self-managed platform. But the good news is also that tiered storage is also coming into Apache Kafka. While I'm doing this recording, some of the first code was already merged into the Kafka trunk. So this is coming into open source too as an interface with tiered storage. And Confluent is working together with other people from the community. Uber has the lead for this tiered storage kit. So this is coming soon, and this is really great for the community. In addition to doing the model training, maybe in the cloud where you can scale up new instances easily for model training in batch. The model deployment is often completely separated, low latency, closer to the edge, with different SLAs than the model training, because this is really the mission critical workloads. With Kafka, this is very easy because you can separate this and deploy this in a hybrid architecture, for example. And as part of this now, with model scoring, it's really super easy to do that with Kafka and your favorite machine learning framework. In this example, we're using KSQLDB, a stream processing engine, which is Kafka native. And here you see it's a very small query, but very powerful. With this query, we have embedded a TensorFlow model into that. And we're doing streaming machine learning at real time for scale, for millions of events with just this query here. So this is how powerful this is. And so to conclude this short session here, this is our architecture with all the Kafka components. Like you've seen in the picture in the introduction. So here we're using Kafka connectivity to the IoT layer, but also to the databases, and also for using it with TensorFlow in this example, for both model training and model scoring. All of that without the need for another data lake like Hadoop or Spark or something like that. So this is not always the best option, but you should be aware of it to simplify your architecture where it makes sense. I've also built a lot of demos for that regarding Kafka together with different machine learning frameworks like H2O, TensorFlow, and more. Take a look at that. There is very simple examples, but also an example about the connected car infrastructure, connecting to 100,000 cars and training data with TensorFlow. That was my session. I hope you liked it. So feel free to reach out to me on LinkedIn and Twitter to stay in touch and let me know if you have any feedback about using Kafka together with machine learning. Thanks for listening.